Yesterday we started with the early concept, and we have seen some of those concepts falling under the monistic and dualistic type. I told you what is the basis for monistic and dualistic concept. The scholars who believe that there was involvement of one heavenly body in the evolution of the Earth and the solar system, those theory or those scholars fall under the monistic concept, right? And those scholars who believe that no, there were two heavenly bodies in the evolution of the Earth and solar system, those theories and they're propounded, they fall under dualistic concept, right? Say I'm in a rush here. Please be very careful here. I'm just giving you a synopsis here because that is not at all part of our syllabus. Number one. Number two, these early concepts are no more valid. Are you getting my point? They are no more valid. Why it is not right? Why it is not asked in the examination? Because that is not the plausible explanation for the origin and evolution of the Earth and the solar system. You know that the most scientific explanation we have till date is Big Bang, right? Big Bang. So we have to go to the modern concept. But just because we are following the background of this discussion, so I'm talking about the early contribution also, right? What contribution we see from the scholars in the early time? Okay, those theories are clear-cut violation of established principles of natural science. That is why they are not at all acceptable, right? They are not at all acceptable. So that is why I'm little bit in rush here. So I have to cover it as quickly as possible, just highlighting the crux or the main I would say the central idea about those theories. So in this line you have the second theory. The first one which we discussed yesterday was your planetesimal theory, right? And now you have this tidal hypothesis given by James Dean in the year 1919, and that was modified in the year 1929 by Jeffrey, right? Harold Jeffrey, he modified that, and this particular theory remained very popular till the end of mid 1950, or you can say till the end of mid 20th century, right? That was the time till this theory remained very popular, especially the modification done by Jeffrey. Okay, so what are the assumptions here? Let us see. James Dean, the original theory in 1919, they believe that this Earth and solar system has evolved from two heavenly bodies, right? What are those two heavenly bodies according to them? The first one is the primitive star, or you can say the primitive sun, and second body according to them is intruding star. This intruding star is much bigger in size than the primitive sun. Now what happens when this primitive star, this is your primitive sun, and you have this intruding star much bigger in size than the primitive sun. It is said is intruding, right? It is nearing to the primitive sun, right? It is coming closer to the primitive sun, right? And what happens because of the pull generated by pull, that means the gravitational pull of the intruding star? As I told you, the larger the body, larger the pull, right? So you have this intruding star coming closer to the primitive sun, and what is happening? You have tidal solar winds, or you can say you have filaments of material being ejected from the middle part of the primitive sun, right? This was in the form of a cigar-shaped filament, just like this, okay? Cigar-shaped filament. That means, when this intruding star came closer to the primitive sun, it was able to exert pull over the primitive sun, and large amount of matter was ejected. It was pulled from the surface of primitive sun in the form of a cigar-shaped filament. Where the end of the filament right, end of the filament are having what? They are having thinner, right, thinner existence. They are having lesser, right, lesser amount of matter. Whereas the middle part of the filament is having larger concentration of matter. And that became very popular because if you see the, right, if you see the solar system, right, our solar system, you'll find the arrangement of the planets. You have Mercury, right? Yes or no? You have Mercury, Venus, then you have Earth, then you have Mars. Yes? The largest planet is Jupiter. Then you have Saturn, then you have Uranus, and then you have Neptune. Right? This is the arrangement. Okay? So when we see the arrangement of the planet in our solar system, right, it is clearly visible that the largest concentration of matter lies in the middle part of, right, middle part of the solar system, right? And that became the rallying point. I said that became the rallying point for this particular theory, and that became very popular, right? So it says that the filament, the cigar-shaped filament, filament of material started ejecting from the primitive sun, and just because the material got separated from the primitive sun, it was attracted toward the intruding star. But by the time this matter could reach the intruding star moved to some other place, right? And ultimately what happened? This filament remained what? This filament remained within the gravitational field of the sun, that means the primitive sun, and then it started revolving around the sun, right? Okay, this is what James Jean has said, okay, right? So this is again just like your planetesimal theory. Nothing, right? Nothing much difference you find here. The only difference is what? In the case of planetesimal theory, they are talking about companion star, approaching star. Here the scholars say it is intruding star, right? Intruding, right? That means one star which intrudes into the domain of any other celestial body, right? Which tries to eat away the domain of other celestial body, right? So it was a very catchy phrase used for the star, right, or for the celestial body, just to give more and more authenticity to the philosophy, right? I would say philosophy because it was not based on any real science. Okay, this is your tidal hypothesis. Now what happened? Right, what happened in say 1929? That will cover our third category, the tri-hybrid concept. Jeffrey in 1929, what he is doing, he is modifying that. Original theory, that is tidal hypothesis, and he says that no, there were no two bodies in the universe. There were actually three bodies, right? There were three bodies. What were those three bodies? One was the primitive sun, right? The other was a companion star, and this companion star was smaller in size than the primitive sun, okay? And then there was one larger star, that was intruding star, right? Later on you'll find Russell in binary star hypothesis. What he has done, he has changed the name of intruding star to approaching star, right? So this is your modification done by Jeffrey, and he is talking about what? See here, the word here is talking about collision, right? Collision hypothesis. So now you can say that the modified version of tidal hypothesis falls under tri-hybrid concept. Keep in mind, tri-hybrid concept where you have involvement of three heavenly body. बहुत clear रखना इस बात को. You have tidal hypothesis falling under dualistic concept. Why? Because the scholar believes in involvement of two heavenly bodies, right? But here you have a scholar who says that no, actually there were involvement of three heavenly bodies, right? And those three heavenly bodies are primitive sun, companion star, which is orbiting the sun, right? Okay, which is orbiting the sun, which is close to sun, okay? And then you have the intruding star coming closer to the companion star. Now what happened when the intruding star came closer to the companion star? It shattered right? There was head-on collision, head-on, right? Head-on collision between intruding star and companion star. Companion star being the smaller one, it was completely shattered, right? It was completely destroyed. And right, and shattering of that companion star led to what? Led to the presence of debris here. That means led to the evolution of debris. That means you are remnant, right? The debris, right? The debris after the shattering of companion star was thrown randomly, right? It was thrown randomly, right? Randomly in the universe. A part of the debris was attracted by the gravitational pull of the primitive sun, right? And that condensed into those planets, right? And sun started revolving around the sun, right? So this is your collision hypothesis. We say that, right? We say that there were involvement of three heavenly body, right? Intruding star was much bigger in size. It came closer to the companion star. Companion star was subjected to, right? It was subjected to complete shattering. It was completely smashed. And smashing of companion star led to distribution of debris here. Debris means debris, right? Debris means the remnant, right? The debris means the material which was derived after the shattering of the companion star, right? This unconsolidated debris, it started being thrown in the universe randomly. A part of the debris was attracted by sun, and sun that started evolving into planet, and sun revolved around the primitive sun, right? This is your collision, right? Collision hypothesis, okay, right? Now what are the problems here? अब हम लोग फटाफट देखते हैं critical analysis, right? What's what, right? Why we do not follow this theories in understanding the origin and evolution of the Earth? The first problem here is critical analysis. The first problem here is what? The scholars say that the stars are separated by great distances, right? They are separated by great distances. It is a remote possibility to assume that one star comes very close to the sun. That is your companion star. And if it is very close to the sun, then why sun is not able to hold that particular star? Right? Because sun is larger in size. Okay? It will have more gravitational pull. So in that case, the companion star must have been pulled toward the primitive sun, right? But that did not happen, right? Second, right? So first point, keep in mind, the stars are, you may write, if you want to write, you write. The stars are separated by great distances. Stars are separated by great distances. Therefore, it is a remote possibility. Therefore, it is a remote possibility to assume a star coming very close to the primitive sun. Coming very close to the primitive sun. And write in the bracket companion star. We are talking about the companion star. ठीक है? हो गया? Now come to the second point. Second point. The second point here is again related to the first one, right? If a part of the debris which was derived out of the shattering of companion star, if that was being held by the gravitational field of sun, then why it was not able to hold that companion star? Are you getting my point? I said the companion star has been shattered, right? Then the debris have been thrown randomly. Then a part of the debris is attracted by the primitive sun, right? Then why it was not able to hold that companion star, right? So write the second point. If a part of the debris derived out of shattering of the companion star, if a part of the debris derived out of the shattering of the companion star is attracted by the gravitational pull of the primitive sun, is attracted by the gravitational pull of the primitive sun, then why it was not able to attract or pull the companion star towards itself? Why it was not able to pull companion star towards itself? Fine. Now coming to second point. Second point here. It says that you have these planets. These planets made up of what? These planets are made up of made up of those lighter material, or those debris which have been derived from the scattering of the companion star. Okay, right? But we all are surprised to know this, that sun is actually concentrated of lighter material, right? Sun has highest proportion of hydrogen and helium, yes or no? Whereas there are planets which are made up of denser elements like iron, right? Like you have nickel, like you have magnesium, yes or no? Calcium, these are denser elements. And you know about the earth, right? I don't have to again talk about this. I'll repeat that later on. But here we all know that earth is the densest of all planets, right? Earth is densest of all planets, and the inner part of the earth is made up of the densest of the mineral, that is nickel, iron, magnesium. These are the densest part, right? So again, this theory fails to explain, right? Why the sun, which is made up of lighter substances, lighter mineral, is able to generate that much of gravitational pull, and those planets which are made up of denser material, they are not being able to attract the pull, or they are not being able to exert pull over the surrounding area. So this is again a problem here, right? So third point you write here. Third point. The planets according to the theory have evolved out of the lighter material, derived from the planets, according to the theory, have been formed out of the lighter material derived from the scattering of the companion star, but actually there are planets, in bracket you write for example earth or inner planet. सारे inner planet के बारे में भी बोल सकते हो, ठीक है? But actually the inner planets are made up of denser substances such as iron, nickel, magnesium, etc. Now last point you write here. Last point. The scholars believe that the planets cannot be formed. The planets cannot be formed out of the condensation of gases, found in a filament according to the tidal hypothesis. I'm taking the critical assessment of both the theory, tidal as well as collision hypothesis. शुरू में मैंने collision के बारे में ज्यादा बोला, ठीक है? One point I have added for right the James theory, that was your tidal hypothesis. Okay, so these are the points you have to keep in mind. Now you can easily understand, right, what's the word, right, what I said, what's the word, I said what relevance you have of these theories are more of mental construction rather than based by or backed by any scientific fact. Okay, so now you know the tri-hybrid concept also. Just to complete this, I'll mention one simple theory here, just 2 minutes, not more than that. Okay. One theory we call it as under tri-hybrid concept. Tri-hybrid concept, you all know, we have involvement of 3 heavenly bodies. Okay, more than 2 heavenly bodies. Okay, so under the tri-hybrid concept, we have seen the collision hypothesis just now. Okay, that falls under the tri-hybrid concept, and then you can include one more here, that is binary star hypothesis. इसलिए सब इसको हम क्या बोलते हैं, hypothesis बोलते हैं, ठीक है? So this hypothesis was proposed by Russell, right? Russell in saying, right, if I am not wrong, the year was 1937. Okay, in 1937, एक बार चेक कर लेना अगर कहीं डाउट हो तो, ईयर में इतना ध्यान देने की जरूरत नहीं है, ठीक है? So it is said of 1937, the year in 1937 you have this hypothesis given by Russell, right? And he said that there were three heavenly body involved in the origin and evolution of Earth, right? The first was obviously, no doubt about this. We have seen all the scholars assume that there was a primitive sun. Yes. Second was a companion star. Companion star. We have just seen this companion star. This companion star is orbiting. This companion star is orbiting in opposite direction to the direction of movement of one more star, and that is which one? That is approaching star. इन्होंने इसका नाम दिया approaching star. This star is rotating or revolving in which direction? Rotating and revolving इस direction में just opposite to the direction of the companion star. ठीक है? अब ये समझना है कि तीन हेवनली बॉडी है, ठीक है? एक प्रिमिटिव सन हो गया, दूसरा कंपेनियन स्टार हो गया, राइट? Companion star and intruding star are having opposite path of movement, right? Opposite, right? One moving in this direction, देखना है मैंने arrow इधर दिया है, and the other moving in this direction, okay? Primitive sun as it is है, जो वहाँ पे पड़ा हुआ उसको कुछ लेना देना नहीं है हमको, ठीक है? Now when this approaching star is coming closer to the companion star, what will happen? Again you all know, right? Just because of the larger size of the approaching star, a pull is generated by the approaching star, and the materials start ejecting out from the surface of the companion star. मतलब इस तरह से bulge बनने लगता है, ठीक है? Right? You have bulge being created on the surface of what? On the surface of the companion star. The pull is being generated, and after some time the material gets separated. Material क्या हुआ? Material got separated from the companion star. Okay? This material obviously is attracted toward the approaching star. ये इसको pull कर रहा है, right? ठीक है? But by the time it can reach the approaching star, it is moving in which direction? Moving away, right? And this companion star in opposite direction moved away. So ultimately, what will happen? Right? What will happen? Again, the primitive sun is able to hold that material. That means the material which could not join the companion star, neither it can join the approaching star, and that material was attracted by the primitive sun, right? That's that material again evolved into the planet, and it started revolving around the sun. ठीक है? ये फिर से वही कहानी है, घिसा पिटा वही पुराना कहानी, ठीक है? मतलब कोई इसमें लॉजिक नहीं है, ठीक है? फिर से वही बात कि अगर उसका मटेरियल को अट्रैक्ट कर रहा है तो कंपेनियन स्टार को क्यों नहीं अट्रैक्ट किया, ठीक है? आर गेटिंग माय पॉइंट? So if this particular part of the bulge part or the separated part of that companion star is being held by the gravitational field of primitive sun, then why it was not able to attract the companion star, right? उसको सॉल्व करने के लिए स्कॉलर ने बहुत दिमाग लगाया और क्या किया, बोला कि देखिए दोनों अपना ऑपोजिट डायरेक्शन में जा रहे हैं, तो दिस सेपरेटेड पार्ट फ्रॉम द कंपेनियन स्टार could not join the approaching star, क्योंकि approaching star ही तो pull generate कर रहा है, right? So it cannot join this one, right? Because it moved away, and companion star too moved away after leaving that, right? After leaving that detached part, right? Detached part from the surface, and ultimately you have say a primitive star, right? That means your primitive star which is able to exert pull over the remaining part of that companion star, and that was subjected to the gravitational field of the sun, and sun started revolving around the parent body, that is your sun. Okay, right? फिर से वही लॉजिक जो मैंने यहाँ पे दिया, ठीक यहीं पे क्रिटिकल एस्पेक्ट में इसको लिखना है, ठीक है? मतलब कि अगर कंपेनियन स्टार को ये अट्रैक्ट नहीं किया तो उसका पार्ट को क्यों अट्रैक्ट किया, ठीक है? If it was pulled by the approaching star, why it could not reach up to the approaching star, ठीक है? So these are hypothetical things. So that's why these all are theories, right? These all are theories which are called as hypothesis. Hypothesis, that means we do not have evidence or fact to support those hypotheses. They are mainly backed by your perception about the universe, right? Perception, not the reality, not the facts. Okay, so in the early concept, just keep in mind that whatever concepts have been given, obviously all those concepts are philosophically very good, but they are not scientifically backed. Okay. So now we are going to follow the modern concept, and under the modern concept, the only modern concept which we rely upon for understanding the evolution of Earth, solar system, as well as the universe is the Big Bang hypothesis. Now again, this is a hypothesis, but I said again this is a hypothesis, but this hypothesis is backed by scientific facts, right? So that is why it is the most acceptable, most scientific, most logical, most comprehensive hypothesis, most comprehensive theory to understand the evolution of Earth, solar system, and the universe, right? So modern concepts were mainly concerned with the origin and evolution of the entire parent body, rather than talking about Earth and solar system itself, right? Because you know that Earth, solar system, they all are part of a parent body, and that parent body is the universe. Okay, right? So Big Bang hypothesis focuses on the origin and evolution of the universe. Once we know the origin and evolution of the universe, that will help us in understanding the origin and evolution of the solar system, as well as the planet. That means your Earth, which is part of our solar system. Okay. So under the modern concept, we deal with this question of the origin and evolution of the Earth and solar system under Big Bang hypothesis that was developed in 1950 to 60. That was the time period. Okay, and it was this hypothesis was based upon some of the observations which were made in 1920, especially by Edwin Hubble. Edwin Hubble suggested that we have expanding universe. Expanding universe. He made that observation in 1921. And when this theory was given in 1960s, what happened after that? In 1972, Cosmic Background Explorer provided many images, many images which suggested for expanding universe, expanding or which authenticated, which approved that yes, the universe is expanding, So this Big Bang hypothesis is basically based on, or it is based on the philosophy of expanding universe concept. Okay, expanding universe concept. Now what this expanding universe concept means? Expanding universe concept simply means with passage of time we have distance between the galaxies increasing. Distance between galaxies is increasing with passing time. Okay. So just keep in mind that expanding universe concept simply means increasing distance between the galaxies, not the expansion of the galaxy. Galaxy does not undergo expansion, right? Galaxies remain as it is, right? It is only the distance between the galaxies that is increasing with the passage of time. Okay, this is your Big Bang hypothesis, right? Now this hypothesis is based on three, I said it is based on three stages of evolution, or origin and evolution of the universe, and those three assumptions or stages suggested by Big Bang are, let us see, the stages in the origin and evolution of the universe. What are those stages? There are three stages. Okay, three stages suggested by the hypothesis. Number one, it says that all the matter, energy, space, time of the present day universe was concentrated at a singular point, that existed at a singular point, that existed in the form of a singular atom, just in the form of a tiny ball. Okay, and the tiny ball was having unimaginable small volume, it was having infinite high temperature and infinite high density. Okay, so the present day matter and energy, not only matter and energy, I would say space and time, everything. Okay, the present day matter and energy, space and time in the universe was concentrated or existed at a singular point in the form of a singular atom or a tiny ball, in the form of a singular atom or a tiny ball. अब देखना थोड़ा इसको समझना है पहला assumption को. This is your tiny ball suggested by the hypothesis, right? Now the present universe is this one. This is the present universe, and what is the main constituent of universe? You all know the main component of universe is galaxies. Galaxies are the main component. Okay, like if universe is a body, which is the main organ of the body? The main organ of the body is galaxies, right? There are billions and billions of galaxies. I said billions. Okay, like you have more than 2 lakh billion, right? 2 lakh billion of billions of galaxies in the universe, and these galaxies are moving away from each other, right? They are moving away from each other. Now this universe is having what? This universe is having matter, right? You all know that matter has 3 states: gas, liquid, and solid. Yes, gas, liquid, and solid. Which is the most dominant element in the universe? I said it is hydrogen, right? 75% of elementary composition of universe is held by hydrogen. The second dominant element is helium. That is roughly around 24.5%, right? And 0.2% is oxygen, right? These are three dominant elements we have in the universe, right? But these three elements are not distributed uniformly, right? There is no uniform distribution, right? There are some knots, there are some localized concentration of those matter. So whatever matter and energy that means, right? Energy, that means the energy which is radiated by those bodies, right? Galaxies have stars, right? And stars are luminous body. You all know that, right? Fusion reaction, you must be knowing the fusion reaction, which is emitting energy from those bodies, and this universe is full with energy, right? So you have matter here, energy here, space. See the space now. The universe is so large, yes, and time. Okay. Now we are in modern time, right? We are in modern time, and we are almost 15 billion years away from that event that took place in geological time, that is Big Bang, right? So if all these four constituents, that means matter, energy, space and time, if they are compressed, move in opposite direction. If they are compressed at a singular point, right? If you compress space, energy, matter, time to a singular point, what will happen to the whole universe? What will happen to the matter? What will happen to the singular point? Obviously, the singular point will have what? The singular point will have unimaginable small volume. Do you agree with this? Volume बहुत कम हो गया ना, because you have compressed the entire energy matter of the present day universe at a singular point. Okay. Then with the compression of entire matter and energy at a singular point, what will happen to that singular point? What will happen to the singular atom? What will happen to this tiny ball? Obviously, the tiny ball will have infinite high density. You know that expansion leads to what? Lower density. Compression will lead to what? Higher density, right? Infinite high density. Now, when the density of the substance increases, what happens to temperature? You know, compression leads to heating, right? Compression leads to heating. So ultimately, it will have infinite high temperature, right? So this is the characteristics of, this is the characteristics of this tiny ball. ध्यान रखना है, tiny ball का क्या characteristics है? It is unimaginable, right? Unimaginably very small, right? It is having very small volume. Number two, it is having infinite high density. And infinite high density, right? High density of the substance means higher, right? Higher compression, and higher compression leads to high temperature, right? That means concentration of heat. Okay. So this is your tiny ball. The characteristics of the tiny ball. Now, now this tiny ball undergoes explosion, right? Explosion हो जाएगा, ठीक है? Second stage. Second stage. The tiny ball undergoes sudden explosion. Sudden explosion, or you can simply say Big Bang. अरे हम लोग बोलते हैं ना bang on, right? Bang on, yes or no? ठीक है? बहुत मतलब जबरदस्त, हाँ? Sudden reaction, yes or no? Right? You are bang on the target, right? ऐसे बोलते हैं ना? So this is your Big Bang, right? Big Bang simply means what? You have sudden explosion, right? You have huge explosion, right? Huge explosion when it happened around 15 billion years ago. 15 billion years ago, right? So this event of Big Bang took place when 15 billion years ago, and what happened then? What happened? Obviously, अब तो simple सा बात है यार. Obviously, the matter, energy, space, time that was concentrated at a singular point, that matter and energy would be thrown randomly in the universe. Yes or no? That matter and energy was thrown randomly in the universe. Initially the expansion. Obviously, when the matter, energy, space is being thrown out randomly, so that will undergo what? Expansion, right? The universe is expanding, and when the universe is expanding, what will happen to the universe now? What will happen to the universe? The universe will undergo cooling. Expansion leads to what? Cooling, right? So this is the Big Bang that took place around 15 million years ago. The expansion was very rapid initially. Later on, the expansion slowed down, right? Later on, it slowed down, and within first 3 minutes, a part of energy was converted to matter, and first atom was formed. Right? First atom was formed within first 3 minutes of that Big Bang. Okay? Energy का क्या हुआ? Conversion, right? And you know that cooling will lead to what? Condensation, right? Condensation will lead to conversion of gases to liquid to solid, right? This is the point you should always keep in mind. When I say matter exists in 3 states, right? Gases, liquid, and solid, right? That understanding will help you a lot when we deal with those topics in geomorphology, right? So this is your first 3 minutes. Within first 3 minutes of that Big Bang, right, a part of energy was converted to matter, and first atom was formed, right? With further progress in time, what happened? Third stage. Within 3 lakh years of that Big Bang, within 3 lakh years of that Big Bang, 3 लाख मतलब देखो 15 बिलियन ईयर्स में हो रहा है बिग बैंग, ठीक है? उसके 3 लाख साल के अंदर क्या हो रहा है? The temperature in the universe decreased to 4500 Kelvin. ठीक है? देखो मैंने पहले बोला कि एक्सपांशन से क्या होगा? कूलिंग, राइट? Expansion will lead to cooling, and temperature in the universe has gone down to 4500 Kelvin, right? Okay, in degrees Celsius you can convert this, right? You know that Kelvin, right? Kelvin can be converted to degree Celsius. Degree Celsius is equal to Kelvin minus 273. अरे यही होता है ना, ठीक है? तो रफली अगर आपको इसको डिग्री में देखना है तो that would be 4226 डिग्री सेल्सियस, ठीक है? रफली, राइट? जस्ट आइडिया के लिए कितना टेम्परेचर हो गया यूनिवर्स में, ठीक है? Now when the temperature started falling, you know the dominant element in the universe, dominant element in the universe, that is hydrogen, right? Hydrogen molecules will combine with each other, right? And ultimately atoms were formed. So atomic matter started forming. More and more atoms were formed. And that was the beginning of physics, ठीक है? यही फिजिक्स शुरू होता है. मालूम है एटम हम लोग पढ़ते हैं, न्यूट्रॉन, प्रोटॉन, राइट? ये सब पढ़ते हैं ना, ठीक है? इलेक्ट्रॉन. तो this is the beginning of physics, right? That means one of the branch of natural science. Okay. So this is your matter being formed. The energy gets converted, The energy gets converted into matter, and that is the beginning of physics. Now that matter, that atom which is formed out of those dominant element in the universe, that is hydrogen, helium, right? What will happen? That means the atoms will collide. They will interact with other atoms, right? When they will interact with other atoms, that will lead to what? That will lead to formation of molecules, right? When those different molecules will combine with other molecules, what will be formed? Obviously, that will give rise to minerals. When those minerals combine together, When those minerals combine together, they will give rise to what? They will give rise to rocks, right? This is how the series of matter start evolving. You know, the lowest constituent of any element in this universe is an atom, right? And from atom to molecule to element to mineral to rocks, right? If you break the rocks, again you can go back to where? You can go back to the atomic level, right? And by formation of more and more atomic matter, what happened? The universe became transparent. Universe became transparent. ठीक है? जैसे इमेजिन करो, जैसे आग बंद करके सोचो कि यहाँ पे ह्यूज एक्सप्लोजन हो रहा है, ठीक है ना? जस्ट इमेजिन करो कि अर्थ के बारे में सोचो, ठीक है? You have huge explosion taking place everywhere on the surface of Earth. So what will happen to what will happen to the surface above the surface of Earth, or what will happen to the surface or the zone which is lying above the surface of Earth? That is atmosphere, you all know, right? So that atmosphere is that atmosphere would be composed of what? Obviously, that would be composed of gases, right? That would be composed of different types of gases, different types of matter. You'll find liquid matter also. You'll find some water vapor also, right? So these are the changing behavior we see in the universe with the formation of matter. What is happening now? Slowly you have matter and energy getting concentrated at some particular location, right? Those locations are called as knots. Those locations are called as knots in the universe, and ultimately what happened? Ultimately the sky became clear, right? You have no gases, right? You have clear visibility. Now you can see the space also, right? You can see the space also. So that was the condition initially when nothing was visible in the universe, right? But with what? With differential gravitational pull, right? Differential gravitational pull, because you know that matter and energy is not being distributed uniformly, right? You have small and big size matter. The big size matter will attract the smaller one toward them, and ultimately they will grow in size, right? They will grow in size. Bigger they grow in size, maximum the pull, and ultimately more and more matter gets drawn towards the bigger body, and ultimately leads to what? Leads to the formation of knots, where we have largest accumulation of hydrogen gases, right? Those largest accumulation of hydrogen gases became the platform for the development of galaxies, right? Galaxies came into existence, okay? And when the galaxies were formed, now the universe became the universe became transparent, okay? Right? This universe came into existence somewhere around 13.7 or 8 कुछ भी लिख सकते हो, 13.7 billion years ago हमारा यूनिवर्स बन के तैयार हो गया, ठीक है? राइट? बिग बैंग कब होता है? 15 बिलियन ईयर्स अगो के आसपास, ठीक है? 15 बिलियन ईयर्स के टाइम में, और हमारा अभी का यूनिवर्स कब बन जाता है? That is 13.7 billion years ago, right? That is the time when the present day universe came into existence. Okay, so these are the three stages, right? Stages suggested by Big Bang hypothesis in the origin and evolution of the universe. I'll further talk about those constituents of the universe, and for that I'll be using one diagram here. Please listen to me carefully, right? Because I'm not going to repeat anything later on, and these topics are of least importance for us, right? Keep in mind, we are just going to take reference of these topics only. Especially we have to keep in mind Big Bang, right? Nothing else, okay? And when you are in the class, please listen to me only, see me only, don't look at the notes, right? You have that note given to you in advance, and you have fair enough time to go through the topics there, okay? So this is your tiny ball which underwent explosion. Explosion हो गया, ठीक है? कब हुआ मैंने बता दिया था, 15 billion years ago, right? B here means billion years, right? Now, right, I just said to you just now that when this explosion took place, matter and energy was not thrown uniformly. right? There was no uniform distribution of matter and energy in the universe. We had uneven distribution, uneven distribution of matter and energy in the universe, and that led to what? That led to existence of differential gravitational pull. And when I say differential gravitational pull, that means the larger size matter were able to draw the smaller size matter toward them, right? And ultimately they grew in size, okay? And that led to what? That led to concentration of those elements at some particular location within the universe, and that led to the formation of the main organ, the main component of the universe, and we call this main component as क्या बोलते हैं? Galaxies. Galaxies came into existence. अब ऐसा समझना है कि जैसे आज भी हम लोग अपने सोलर सिस्टम के बारे में बात करते हैं, right? We have atmosphere, yes. Through this atmosphere, we can see the space also. By high resolution telescopes, we are able to see the space also, right? Yes or no? Which means that the universe is, that means the universe in our with respect to our solar system is transparent, right? Why it is transparent? Because the matter and energy in the universe is not uniformly distributed, that is concentrated along some knots, right? Along some localized places. Those localized places are your knots, right? Okay? So when that matter and energy got concentrated at some knots in the universe, knots सीधा बोलते हैं, knots का मतलब होता है a localized concentration of a high and dense concentration of matter and energy, that is called as knots, right? These knots became the platform for the development of galaxies. Okay? Galaxies. So what are those galaxies? Galaxies are, keep in mind, galaxies are the largest nebula. याद रखना है, यूनिवर्स में सबसे बड़ा नेबुला कौन सा है? गैलेक्सी, मतलब मैंने बोला यूनिवर्स में सबसे बड़ा नेबुला कौन सा है? नेबुला देखो हमेशा इस वर्ड का हम लोग रेफरेंस लेते रहेंगे, ठीक है? नेबुला इज व्हाट? प्लीज डिफाइन व्हाट इज नेबुला? Yes, a cloud of gas and dust, right? A cloud of gas and dust is called nebula. The largest nebula which we have in the universe is a galaxy. Yes, is this point clear? Now, these nebulas are made up of what? Which is the most dominant element in the universe, my friend? They are mainly comprised of hydrogen and helium. Okay? So nebulas, these nebulas, those galaxies are nothing but the accumulation of hydrogen gases, right? Accumulation of hydrogen gases at some localized places, some knots in the universe, and they became the base for the development of galaxies, right? So galaxies are large accumulation of hydrogen gas. ठीक है, याद रखना है, galaxy क्या है? Large accumulation of hydrogen gas found in a concentrated form, right? Concentrated. So you have concentrated existence of hydrogen gas in those galaxies. ठीक है? These galaxies came into existence when? These galaxies came into existence somewhere around 10 billion years ago. सारे galaxies बन गए, ठीक है? बात समझ में आ रहा है? 10 billion years ago, the galaxies came into existence. Again, this timeline is not important. This is just for reference, right? Not for your means examination. Okay. Now let us follow the next point. Galaxies have been formed. You know what is galaxy? Large accumulation, right? Large accumulation or accumulated presence of hydrogen gas along some knots in the universe are your galaxies, right? These are your galaxies. But within these galaxies, याद रखना galaxies में क्या हो रहा है? The galaxies are, with the passage of time, the galaxies are moving away from each other, right? They are moving away from each other. Okay? They are moving away from each other. Fine? That is your expanding universe concept. Galaxies do not undergo expansion. Galaxies खुद से नहीं expand करते, ठीक है? मैंने आपको कल ही बोला कि you have some you have some some groups of scientists claiming that the galaxies are expanding, but that was an aberration, right? It has been countered by the official statement of NASA, and now we are again back to the basics, right? And we believe in what? We believe in expanding universe concept, right? That means the distance between galaxies, are increasing, with the passage of time. Okay? Now these galaxies, are having large concentration of hydrogen gas, helium gas, primarily it is hydrogen gas. But distribution of hydrogen and helium gas within the galaxy, within this nebula, the large nebula is not having uniform distribution of matter and energy, right? Again, the gases are not found uniformly distributed within the galaxies, and that leads to what? That leads to formation of clumps. These clumps are nothing but localized and concentrated presence of gases. और gases का जब भी मैं बोलूं आप समझ जाना, I'm talking about hydrogen and helium, right? तो नेबुला के अंदर भी क्या है? नेबुला के अंदर भी यूनिफॉर्मिटी नहीं है, ठीक है? नेबुला also does not have uniform distribution of density, right? Nebula too has those knots. ये क्या है? फिर से knots ही है, right? These are your localized and concentrated presence of gases, which are called as क्या बोलते हैं? Which are called as clumps. Okay, like you must have seen, you add water to a wheat flour, right? You take wheat flour in a utensil and add water. If you are not kneading it, what happens? You find clumps. Yes or no? If you are not kneading it properly, you will find clumps. Okay, so that clump is what? Concentrated presence of that wheat flour, right? Okay, the same logic you can apply here, right? And that will make you comfortable to understand what is this clump. So clump is nothing but the concentrated and localized presence of hydrogen gas, right? And these clumps are further developing into what? These clumps are further developing into two structures. One is the inner core, the other is the outer layer, right? So the clumps undergo what? The clumps undergo further that density differentiation, where the denser matter is proceeding toward the center of the clump, and then the lighter one is lying along the margin of the clump, right? So my friend, keep in mind, these clumps are what? This is the beauty of Big Bang, Big Bang hypothesis, because it believes in the same process, right? Same process है, चाहे वो यूनिवर्स का फॉर्मेशन हो, चाहे वो गैलेक्सी का फॉर्मेशन हो, चाहे वो स्टार का फॉर्मेशन हो, whether it is related to formation of Earth, right? It believes in the same process, right? And it also believes in the fact that all the celestial body in the universe, they have evolved from the same, from the same matter in the universe, right? एक ही जगह से और एक ही मैटर से बने हुए, ठीक है ना? तो लार्जेस्ट नेबुला कौन सा है? मैंने बोला गैलेक्सी। उससे छोटा नेबुला कौन सा है? Stars, right? Because these clumps will give rise to what? These clumps will give rise to stars. Stars का formation होने वाला है, ठीक है? Is this point clear? You know that one galaxy contains billions and billions of stars, right? Let me talk about our own galaxy, right? Our Milky Way galaxy has 1 lakh, कितना? 1 lakh billion star. 1 lakh billion star. One of the star is sun, right? लेकिन हम लोग अपने आप को ही सुपरस्टार समझते हैं कि हम लोग से बड़ा कोई है ही नहीं, ठीक है? मैंने बोला हम लोग एक स्टार है उसमें से, और कितना? मैंने बोला 1 lakh billion. 1 billion is equal to 1000 million, right? 1 million is equal to 10 lakh. आप मल्टीप्लाई करते जाओ कितने स्टार्स है, right? One of the star, that hosts our solar system is sun. Yes or no? Is sun. Now this clump, Now this clump undergoes what? This clump undergoes differentiation under internal gravitational pull. Internal gravitational pull. So under internal gravitational pull, what is happening now? What is happening now? The denser material is proceeding toward the center of the clump, right? देखो clumps में भी याद रखना, अब ये जो clump बना क्या है, उसमें भी uniform distribution नहीं है, right? Again you'll find the denser one, right? Denser one proceeding toward the center and the lighter one remaining in the outer, right? Outer, you know, in the fringe area, or you can say that toward the outer surface, right? So because of this internal gravitational pull, what is happening? What is happening now? Now this clump is developing into a core having high density, right? And this core is surrounded by, ध्यान से देखना है, इसको मैं हटा रहा हूं, आप core से समझ जाना, मैं मतलब core कैसा है, denser है, ठीक है? A denser core surrounded by again a cloud of gas and dust. Again a cloud of gas and dust having low density. Yes, this core has become what? This core has become क्या? Sun. Sun बन गया, ठीक है? Stars came into existence between 5 to 6 billion years ago. ये सारे स्टार्स का लाइफ है, ठीक है? जैसे हमारे सन का भी लाइफ करीब, ठीक है, करीब 6 बिलियन के आसपास हम लोग बोलते हैं, ठीक है? And the solar system came into existence around 4.6 billion years, right? Billions ago. तो सन का जो आधा लाइफ है खत्म हो चुका है, right? Half of the life of sun is over, right? खत्म हो चुका है. That means 3 billion years have already been consumed, right? We are left with another 3 billion years, right? 3 billion years का और लाइफ बचा हुआ है. I mean that is calculation done on the basis of the energy, right? Energy, you know, concentrated, right? The energy released by sun, right? Under that process of fusion, right? Fusion, ठीक है? एक समय आएगा जब सन कैसा होगा? After 3 billion years, the sun will dim out, ठीक है? ठीक है? कोई लाइट रिलीज नहीं करेगा, कोई एनर्जी रिलीज नहीं करेगा. Ultimately, what will happen? The whole solar system will die. ठीक है? Because we are existing on what? We are existing on one source of energy that is coming from sun. You talk about any activity, you talk about physical activity, you talk about, you know, chemical processes, you talk about geochemical processes, you talk about any process, you talk about natural, right, man-made processes, anything I said, we are dependent on sun, right? Okay, so if the sun is gone, we are also gone, right? So this is your internal gravitational pull within the clump that is leading to the development of a core, and that core is surrounded by again a cloud of gas and dust, and this cloud of gas and dust could be called as what? फिर से नेबुला, ठीक है? याद रखना सबसे बड़ा नेबुला कौन सा है? गैलेक्सी, ठीक है? और सबसे छोटा नेबुला कौन सा होगा? If you follow the order of celestial body, the smallest nebula would be the satellite of the planets, right? Satellites of the planet, ठीक है? They are the smallest one. See, उसके बाद भी you must have heard about asteroids. अरे ये सुनो, belt of asteroid that lies between Mars and Jupiter, right? What is that? That is the leftover of that process, ठीक है? जो बचा कुछ रेसिड्यू है, जो बच गया है, ठीक है? जिसका कुछ हो नहीं पाया, ठीक है? कंडेंसेशन नहीं हुआ, क्या पता आगे क्या हो जाए, ठीक है? So this is your nebula, and this cloud of gas and dust is undergoing what? This cloud of gas and dust undergoes differential gravitational attraction and undergoes cohesion, right? That means this cloud of gas and dust undergoes पहला कंडेंसेशन होने लगेगा, ठंडा हो रहा है. याद रखना है कि पूरा का पूरा यूनिवर्स अब ठंडा हो रहा है, ठीक है? तो what will happen? Condensation will lead to what? Condensation will lead to conversion of gas to liquid to solid. धीरे धीरे ऐसे होने लगेगा. टेम्परेचर जितना कम जाएगा, जो गैस है वो क्या करेगा? गैस जो है वो लिक्विड और लिक्विड से सॉलिड में कन्वर्ट होते जाएगा, ठीक है? Condensation started, and with condensation taking place, what happened? The gases evolved into those small particles. That means small round shaped particles, right? These small round shaped particles, they had differential gravitational pull. फिर से यहां देखते हैं कंडेंसेशन हो रहा है, ठीक है? इस नेबुला का तो क्या होगा? You you have billions and billions of such small round objects, right? Small round objects of varying size. कोई बड़ा है, कोई छोटा है, ठीक है? Small, right? Small round object of varying size. Yes, ठीक है? Now, if say the objects are of right, if the objects are right, if the objects are of varying size, obviously that will lead to what? That will lead to what? Differential gravitational pull, right? जो बड़ा है वो क्या करेगा? छोटे को अट्रैक्ट करेगा, right? The smaller one will be attracted toward the bigger one, yes, and ultimately that leads to what? Ultimately that leads to cohesion. Cohesion होने लगे. Cohesion means what? Cohesion means attachment, right? Attracted and the smaller body got attached with the larger one, right? Now cannot be separated. That became integral part of the right. Integral part of the body which has attracted, right? Attracted such smaller bodies, right? And ultimately that led to what? Ultimately cohesion led to evolution of small round objects. Those small round objects were called as, क्या नाम पड़ा उसका? फिर से याद कर लेना जो हम लोगों ने थ्योरी पढ़ा था, planetesimal theory, right? ठीक है? Planetesimal. That means right. That means this differential gravitational pull has led to evolution of many millions and millions, I would say, right? Millions and millions of such small round objects, right? I said small round objects, small, छोटे, ठीक है? Small round objects were formed. Those small round objects of I would say small round objects in numerous number. They are called as planetesimals, ठीक है? है ना? छोटे छोटे, ठीक है? There were many such, right? Millions and millions of such small round objects, and those small round objects were called as planetesimal, right? Now again, this planetesimal could be of, right? Again of different size. कोई एक जैसा तो होगा नहीं, ठीक है? कोई planetesimal थोड़ा बड़ा होगा और कोई थोड़ा छोटा होगा, yes? ठीक है? और फिर से क्या होने वाला है? The next step was the planetesimal underwent collision. Right? They collided with each other, right? They collided with each other. Now when the larger planetesimal were able to attract the smaller one, right? They further grew in size and collision led to what? अगर मान लो ये दोनों collide करेंगे तो क्या होगा? अरे collision will lead to friction. Friction will lead to what? Friction will lead to wear and tear. अरे disintegration, yes or no? The disintegrated material would be thrown where? Just in the vicinity of those planetesimal, and that would be attracted by again those large planetesimal, right? And ultimately what happened? Collision led to accretion. थोड़ा प्रोसेस आपको ऐसा लगेगा कि क्या ये सब बार बार एक ही बात हो रहा है, ठीक है? लेकिन सारा इंटरकनेक्टेड है, ठीक है? accretion का मतलब क्या होता है? Addition of more and more mass to the existing body, right? More and more mass were added, right? And how that mass was added? I said collision led to what? Friction, breakage, throwing of the debris in the universe, and a part of the debris was attracted by those planetesimal, and they started growing in size. Accretion led to development of those planetesimal into what? Into large size objects, and those large size objects were called as planets. Planets बन गए, ठीक है? Right? Planets were formed. तो 4 स्टेज याद रखना है. पहला condensation, right? Second step is differential gravitational pull and cohesion. Third is what? Collision, and fourth is accretion, right? That led to the formation of planet. अब याद रखना है, अभी भी तो leftover होंगे ना? Still you will find the gases, right? Gases and dust in the universe. आज भी हमारे solar system में है, ठीक है? So these gas and dust are surrounding, right? Are surrounding what? Obviously, the planets are surrounded by gas and dust, and they will undergo the same process. What is that process? अभी तो हम लोग ने बात किया ना, condensation, differential gravitational pull, cohesion, right? Collision, accretion, and that will lead to what? That will lead to the development of what? Satellites. ठीक है? अब जो बचे कुछ बच जाएंगे वो हमारे लेफ्टओवर है, आज भी यूनिवर्स में दिखता है, ठीक है? So this is how the satellites have evolved, right? So our solar system came into existence around 4.6 billion years ago. ये हमारा टाइम पीरियड है जब हमारा क्या हुआ, सोलर सिस्टम केम इनटू एग्जिस्टेंस. ठीक है, क्लियर? यस. मैंने कोलिजन बोला कि मान लो हम दोनों कोलाइड कर जाए, ठीक है, कुछ मेरा पार्ट टूटेगा, कुछ आपका पार्ट टूटेगा, and that would be right, that would be thrown, and ultimately the bodies which are in the vicinity, that means the larger planetesimal, they would be able to attract that टूटा फूटा पार्ट. मेरा पार्ट टूट के गिरा हुआ है तो कोई तो खींचेगा उसको अपनी तरफ, राइट? सो दैट कोलिजन led to friction and disintegration of further disintegration of those planetesimal, and the debris which were derived from the planetesimal that was attracted by the existing number. There are millions and millions of such round objects, right? And further they underwent accretion. Accretion मतलब addition of more and more mass, right? आप अट्रैक्ट करोगे तो आप मान लो मेरे बॉडी में और इधर हम अब क्या करें, थोड़ा और मास ऐड कर देते हैं, ठीक है, जिम करते हैं, प्रोटीन खाते हैं और बॉडी बना लेते हैं. आई एम एडिंग मास, राइट? So this is how the planets started evolving under the process called accretion. ठीक है, ये सबसे हम लोगों को प्लॉजिबल लगता है. मतलब देखो एग्जैक्टली क्या हुआ है ये किसी को नहीं पता, ठीक है. वी आर ट्राइंग टू रिकंस्ट्रक्ट द हिस्ट्री ऑफ अर्थ, राइट, and the universe. Okay, so it is bound to have some error, right? कुछ तो error होगा, इसमें कोई शक नहीं है. But the most I would say logical explanation which we have till date is your Big Bang, right? Big Bang जो है हमारा logical explanation देता है, ठीक है. इसलिए हम इसको सबसे ज़्यादा एक्सेप्ट करके चलते हैं कि हाँ ये, और इसका सबसे बड़ा मेरिट है इस मॉडल का, वो ये है कि the model and the processes remain same, right? I said the processes remain same for the formation of all celestial bodies in the universe, right? With some exception, बड़ा exception है, right? And that exception is seen in the case of Earth also. You know that Earth has only one moon, Earth has only one satellite, है ना? ठीक है? But this satellite or the moon of Earth has not evolved out of the process which I discussed just now, right? Okay, a unique event took place right? One unique event took place in geological time. That means at the time of the evolution of Earth, because the Earth was not in a solid state, the Earth was still very volatile. It was a gaseous nebula. याद रखना है. अब planet बन गया. Planet का मतलब ये थोड़ी होता है कि ये solid हो गया, नहीं. It will undergo what? It will undergo internal, right? It will undergo internal modification, right?